We will be looking at organic chemistry, and we are taking this question from the November 2014 grade 12. So I am going to deliberately take the long way around in doing these questions, and this is because I want to try and explain as much as I can so that you're able to understand how to answer these questions yourself. Consider the organic compounds represented by the letters A to F in the table below. So the first step that I would recommend that you do is to not even look at the questions. You want to look at the organic compounds that you're given and then try and represent them in structural formulae, and then try and identify their functional groups, and then maybe try and name them as well before you even look at the questions. So I'm going to start with A. A. I have 2,2,4-trimethyl-hexane. Hex means 6. That is the prefix. So I'm going to have 6 carbons. 1, 2, 3, 4, 5, 6. And then I'm just going to number my carbon atoms. Okay. And then in carbon number 2, I am going to have 2 methyl groups because I have a 2,2. So this is going to be CH3. And then I'm also going to have another CH3 there. And carbon number 4, I'm going to have another methyl. So this is obviously an alkane. And then the name is already there. And then I'm going to move to B. I have 1, 2, 3, 4, 5. So I have 5 carbons. 1, 2, 3, 4, 5. In the first carbon, I have three hydrogens. In the second carbon, I have 2 hydrogens, 2 again, 2. And then in the last carbon, I have an oxygen, and then that carbon is bonded to the hydrogen. So the carbonyl group there is where it is at the terminal the terminal carbon, and I have a hydrogen that is attached to that carbon atom. This can only be an aldehyde. When you have a hydrogen attached to a carbonyl group at the terminal, that is an aldehyde. So this is an aldehyde. And then what is the IUPAC name? So we are going to, when naming, the first step it is to identify the longest continuous chain, ensuring that the functional group is part of that chain. The functional group of aldehydes is that. And then I'm going to number my carbon atoms. So this is 1, 2, 3, 4, 5. Or I can number from right to left. 2, 3, 4, 5. We said that when you number your carbon atoms, the functional group must get what? The least possible. So you can see that with the blue color, that functional group is at carbon number 1. So I am going to number my carbon atoms from right to left. 4, 5. And this is going to be, I have 5 carbons, So it is going to be pentanal. And then C, that is a haloalkane. I don't need to draw the structural formulae. Okay, so now let's try and name it. So I can either not, okay, the first step is to identify the longest continuous chain and then ensure that the functional group is part of that chain. So this is the longest continuous chain. Okay, and then now I need to number my carbon atoms. 1, 2, 3, 4, 5. Or I can number from 1, 2, 3, 4, 5. Well, as you can see, with the red color, the functional group is at number 2, but with the blue color, the functional group is at number 3. Don't forget, this is a haloalkane, so the functional group must be what? A halogen. Although we do have a methyl group there, it is not correct numbering using the blue color. Okay. So now I need to look at what? The side groups. That is a side group. And then I have a chlorine and a bromine. And then I'm going to name these in alphabetical order. So B comes before C. So 2 bromo, 3 chloro, and then I have my methyl group at number 4. 4 methyl, and then I have 5 carbons. So this is going to be pentane. Okay. With D and E, you just need to study your polymers and then commit them to memory. Number D is going to be polyethylene, and then number E is going to be a condensation polymer. So D, that is and then E, that is a condensation polymer. And then now we'll look at number F, letter F. Pentan means 5. So I'm going to have 5 carbons. 3, 4, 5. And then I'm going to number my carbons. 1, 2, 3, 4, 5. And then we are saying at number 2, we have an one. So at number 2, so that is a ketone. Yeah. Then now we can tackle the questions. 2.1.1. Write down the letter that represents the following. An aldehyde. That is going to be B. 2.1.2. A condensation polymer. That is E. A compound which has a carbonyl group bonded to 2 carbon atoms as its functional group. That is a ketone. And this is because this is a carbonyl group, right? And then I am told that this carbon should be bonded to 2 carbon atoms. So this is a ketone. That is going to be F. Okay. 2.2.1. They want the IUPAC name of compound C. It's already there. It's 2 bromo, 3 chloro, 4 methyl pentane. And then 2.2.2. the monomer of compound D, that is going to be ethene. 2.3. Write down the structural formula of compound A. You already have that. It's right there. So this is going to be, and then we have okay, 2.3.2 compound F. Again, if you want the explanation, you can always rewind the video to the beginning where I explained where these are coming from. And then 2.4. The table contains compounds which are functional isomers. Define the term functional isomers. So functional isomers are compounds with the same molecular formula but have different functional groups. 2.4.1, 2.4.2. Write down the letters that represent two compounds that are functional isomers. So that is going to be B and F. B and F. So now let me explain. So you have 1, 2, 3, 4, 5. You have C5, H3, 5, 7, 9, 10. H10, and then an oxygen. This is for B. And then for F, you also have you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're going to have C5H10 and then 1 oxygen. So you can see that these two, they have what? The same molecular formula, but they belong to what? To different functional groups.